first step in factoring is always to check to see if every term has a common factor. First, we'll start with the numbers. The biggest factor that can divide into 28, 16, and 80 is 4. So we'll divide out or factor out the 4. Then we'll start with the variables n. Every term has some n's. So what's the most number of n factors that we can take away from everybody? We can't take away 4 factors of n from this term or this term. We can take 2 factors of n away from this term and this term and this term. So that is what we factor out. And then what remains? After you divide out, factor out 4n squared from this term, you're left with 7n squared. When you divide 4n squared from this term, you're left with 4n. Minus, and then when you divide 4n squared from this term, you're left with 20. If you're wondering where these things come from, if we were to go backwards from the second line to the first line, we would have to multiply and use the distributive property. And 4n squared times 7n squared is 28n to the fourth. And 4n squared times 4n is 16n cubed. And 4n squared times 20 is 80n squared. Alright, so this expression's been factored, but it might not be factored completely because we might be able to factor this red trinomial. So remember that this will be a binomial, which means 2 terms, and this also will be a binomial. And the first term times the first term in this set of parentheses, and the first term in this set of parentheses, first times first will give us this first term. So that means we'll have a 7n and 1n. 7n times n is 7n squared. Now, for these boxes, which is the last term and the last term, when you multiply them, we'll get the last term. The thing is, there's a lot of ways we can multiply last times last and get last. Negative 2 times 10, positive 2 times negative 10, positive 4 times minus 5 is a negative 20, a negative 4 times a positive 5 is negative 20. How do you know which one it's going to be? Well, whatever you put in there, when you multiply this number here by 7n and this number here by 1n, we're going to combine those, and together we should get 4n. Here's an example of a combination that doesn't work. The blue first times first does give us the first, and the black last times last does give us negative 20 the last. However, when we multiply 7n times negative 5, we get negative 35n, and that's the outside product. And the inside product is 4n. And when we combine these, we get negative 31n, which is not how many n's we have. So we need to try a different way of multiplying last times last to get last. It ends up being minus 10 or negative 10 and a positive 2. When you multiply that, you get negative 20. And the outer product is 14n, and the inner product is negative 10n. And when you combine those, you get positive 4n, which is what we needed. So this is the final answer. We can't factor anything anymore. This is the answer factored completely. Alright, I'm going to quickly review some things you might have remembered from algebra class last year, depending on how your teacher taught you how to factor this red quadratic trinomial. Some teachers use this X model. I think Ms. Childs or Mr. Hagen calls it the X games. A times C is negative 140. Put that number on top. The B term we put on the bottom, just the coefficient 4. So we're looking for these two numbers, which multiply to give us negative 140, and which add to give us 4. These are the numbers we're looking for. 14 times negative 10 is negative 140. 14 plus negative 10 is 4. Now what do we do? Again, this depends on how your teacher taught it last year. Some teachers will use a box and they'll put this first term here and the last term down there. Then on the outside, these will get multiplied to give us what's in the box. So n times 7n is 7n squared. And what we put here and here have to multiply to give us negative 20, but we'll use our answers to the x model to put in these empty spaces. But we'll attach the variable n to them. So the 14 will become 14n, and the negative 10 will become negative 10n. And then we have to ask, what would we multiply here in blue by 7n to get 14n? And that would be 2. And then over here, n times this blank has to give us negative 10n. So n multiplied by negative 10. So everything checks. N times 7n is 7n squared. 2 times 7n is 14n. 2 times negative 10 is negative 20. And n times negative 10 is negative 10. So our final answer is in blue. N and 2 multiplied by 7n minus 10. Okay, now there's another way we could have factored this once we've solved this puzzle of this x model, and that would be to rewrite our expression by changing the 4n to the sum of this many n's, 14 n's and negative 10 n's. If we combine these, we still get 4n, which is what our original problem had. But now we have a polynomial with 4 terms, and this is where we factor by grouping. So maybe you remember doing this last year. In this group, the GCF is 7n. So we'll factor out, just from these two terms, the GCF of 17n. And we're left with n plus 2. And now from this group, we'll factor out the common factor of a negative 10, which goes into both of them. And what's left is n plus 2. As we look here now, this term has an n plus 2 factor, and so does this one. So we will factor out that factor of n plus 2. And what's left is 7n minus 10. So either way we do it, we get the same answer. But there are still other ways we can factor 7n squared plus 4n minus 20. There's the x model followed by this table. There's the x model followed by factored by grouping. And there's a couple of other ways. And maybe one makes the most sense to you. That's the one you should work with. Let me show you the other two ways quickly. You may remember the FOIL method. The first term times the first term must give us the first term. That's the F in FOIL. There's only one way to do that, 7n times n. Now we might focus on the last terms, which are here and here. The product of last times last will be the last term, negative 20. However, we need to keep in mind also that the outer product, which is this term times this term, and the inner product, which is this term times this term, that's the middle part of FOIL, and that will give us the middle term. So whatever we put in this green box gets multiplied by 7n, and this green box gets multiplied by n, and those n terms need to combine to give us the middle term The middle part of FOIL gives us the middle term. Well, for the green boxes, which is the last term in this group and the last term in this group, last times last needs to be negative 20. So last times last, that is the green boxes, have a lot of possibilities. These have a product of negative 20, so do these two factors, and these two, all these do, but only one of them is going to help us to get 4n on the inside. So it's a lot of guessing and checking. If you imagine a 2 and a negative 10 going in that position, the 2 and the negative 10, we'd have 2n and negative 70n. That's negative 68n. That's not going to work. So then we can try the negative 2 and the 10. Negative 2n and 70n, still not going to work. We can try the 4 and the negative 5. 4n and negative 35n does not combine to give us 4n. We can try the negative 4 and the 5, negative 4n and 35n. It does not have a sum of 4n. We can try 1 and negative 10. So 1 there is 1n, and then negative 10 times this is negative 70n. Those don't combine to give us 4n. Then we can try negative 1 and positive 10, negative 1n, and 70n is not 4n. So you might think it's not factorable, except changing the order of these are 6 more possibilities. Changing the order around for our green boxes, that is, the product of these two numbers, last times last, will still give us last. Every product is negative 20. But now to get the middle term, doing the middle part of FOIL, the outer product and the inner product, let's see what we get. If we put the negative 10 in the first green box and the 2 in the second green box, we'd have negative 10n, and 2 times 7n is 14n. Oh, there it is, negative 10n. If we put the negative 10 here, and if we put the positive 2 there, we'd have 14n. And when we combine these, we get our 4n. So there it is, using just FOIL with a lot of guessing and checking. The last way I'll review, or maybe this will be the first time you're seeing this, is kind of bizarre, but it does work every time one of these things is factorable. So this bizarre method says, just ignore that 7. Well, don't really ignore it, but take it and multiply it by that last term. So we took this 7, kind of made it disappear, but we multiplied it by negative 20 to get negative 140. Now factor this if you can. And this is a lot easier than factoring it when it had a 7 in front of n squared. So we're back to, if you use the x method, 1 times negative 140 is just negative 140. We put that number on the top. And then we put the b term on the bottom, which is 4. And we're trying to multiply to get negative 140 and add to get 4. Two numbers which multiply to give you negative 140 and add to give us 4, but we've seen this already. It happens to be 10 and 14. Product has to be a negative 140, so one of them is positive and one is negative. And when we add them, we need to get a positive 4. So 10 would be negative and that would be 14. And now at this stage, you can just put those numbers in. Positive 14 minus 10. But then this 7, which we just kind of made disappear, we're now going to divide that 7 just by the green parts. Simplify these fractions if we can. And this one doesn't simplify at all. And after you've simplified the fractions, take that denominator and just put it right there. So we get the same answer as before. but we've reduced the amount of guessing and checking. I'm going to complete number 15 rather quickly, but I'll show multiple ways of doing it. However, if you need more than a quick demonstration, then you should watch the video on number 10, where I more slowly go through the review of how to factor these trinomials. The first strategy I'll show is the grouping strategy. First, we factor out the GCF, and the only factor in common with these three terms was r. Notice that if we went backwards and multiplied r by every term, we would have the problem that we started with. The grouping strategy is going to tell us how to break up this 73p into a combination of two terms of p's which add up to 73p. We start by multiplying the a term, not times the b term, but by the c coefficient. So 9 times 70 is 630, we put that on top, and the middle coefficient b we put on the bottom. We put the multiplication symbol on the top and the adding symbol on the bottom, and we're looking for these two numbers, which will tell us what's going to go here, such that they multiply to give us 630 and they add to give us 73. This number is big, but it's not too hard to see that the first easy way to factor this, 63 times 10, actually adds up to 73. Do pay attention to the signs as well. So positive 63 times a positive 10 is 630, and 63 plus 10 is 73. So this tells us how to break up the 73 p's. 63 p's and 10 p's. It's the same thing as 73 p's, but now when we have four terms, we can factor by grouping. With the first group of two pairs, factor out the greatest common factor, which is 9p, and when you factor out 9p, we're left with just p plus 7. You're essentially dividing by 9p. Also, to check your work, going backwards from this step to the line above it, we have to distribute 9p times p is 9p squared, check. Plus 9p times 7 is 63p, check. Then in the second group, in the grouping strategy, do the same thing. Is there a common factor here? If there is, factor it out. The common factor, the greatest common factor was 10, and after you factor it out, we're left with p plus 7. So notice at this stage, and we're ready for the last step, we have a p plus 7 and a p plus 7. So we'll factor that out. Factor out that p plus 7, and what does it have to get multiplied by? P plus 7 has to get multiplied by 9p plus the p plus 7 has to get multiplied by 10. And now this problem is factored completely. Alright, let's look at it another way. With the table method, we still have to factor out the GCF out front. And then we still have to do this strategy, but once you do the strategy with the table method, you make your table. In the table, we'll put the 9p squared upper left corner and the positive 70 in the bottom right corner. And then the solution to the little x puzzle goes into blanks, but they actually have a p, like that. And then on the outsides of the rows and columns, we're going to put the numbers which end up being the leading right to the answer. On the outside, the row value and the column value will multiply to give you what's in the box. This is my least favorite method. I much prefer the grouping method we showed earlier, because it's not always clear to students what goes on the edges. So if you tried 9p times p, that gives you 9p squared, but then 9p times what gives you 63p, 9p times 7 gives you 63p, and 7 multiplied by what gives you 70, that would be 10. So does everything work? P times 10 is 10p, p times 9p is 9p squared, 7 times 9p is 63p, and 7 times 10 is 70. This works, and there's our final answer. Let's go ahead and write it up here. P plus 7 and 9p plus 10. Alright, let's look at another kind of strange way of doing it. I don't have a name for this way, but I'm just going to call it the strange way for factoring the red part. This way strangely just removes the 9 and multiplies it times 70. And then this way we'll factor this, which is easier than factoring that because of the leading coefficient being 1. Let's go ahead and factor these three terms over here. First, the number on top is a, which is 1 times c. So 1 times 630 is 630. And then on the bottom, we put the b term, which is 73. Alright, then what goes in the boxes are two numbers that multiply to 630 and two numbers that add to 73. So again, we're thinking of the 63 and the 10. 63 and 10 multiply to 630 and they add to 73. So we come over here and write those numbers in, p positive 63 and p positive 10. And then that 9 that we disappeared and made go away right here, but we multiplied it by 630, well now we're going to kind of put it back by dividing by 9, but just over these two numbers, into these two numbers. So we're going to put a 9 there, and now we're going to simplify the fractions if we can. 63 divided by 9 is 7. And this one doesn't simplify. And once you're done simplifying and you get as far as you can, if you've got a denominator, you put that denominator in front of the p there. And that's your final answer. And it's the same as the other two strategies that we used.